Hey folks, it is Lee, the Teen Librarian at the Upper Darby Township Library, coming to you with this month's STEM Shenanigans. So this month we are going to be testing out air pressure and what effect cold and heat have on air pressure. So first step of your project, what do you need, right? Okay, so really super simple this week. I didn't even put together a kit because I am certain that you probably have most of these things, if not all of these things, lying around your house. So what do you need? You need a plastic bottle, and by that I mean like a single serving water bottle or a Coke bottle, soda bottle, whatever, right? A single serving plastic bottle. You need a paper towel and a way to get it wet. And you need a coin. We're going to test a couple of different coins, so you can do that if you want to. If you have I'm going to use quarters and dimes because they are, the most different. So I've got some of each ready to go. I've got several bottles lined up here because I want to see what difference size makes on them. I want to see what difference the size of the coin makes on them. And I actually also have one glass bottle to see if it works with glass. So we're going to get started. I meant to film myself putting the bottles into the freezer because that's step one, but I didn't, and it would have been really boring anyway. So I'll show you my bottles in the freezer. You get a behind the scenes look at the Sellers Library staff kitchen. It's very glamorous. And here is our freezer. And inside you can see several water bottles. So I've got a glass bottle, I've got a plastic bottle, there's another plastic bottle back there, and there's two little plastic bottles here. So all of these have been in the freezer for about an hour, okay? And what that's gonna do is cool down the air that's inside the bottles. They're open, there's no cap on them. We're just literally cooling down the air in the bottles, okay? And what happens when we do that is that air compresses, gets smaller when it cools. Kind of the opposite of water, actually. Water, right, it expands when it gets cooler. Air, theoretically, right, we're going to test it out. Air, theoretically, gets smaller, compresses as it gets colder. So what's happening in there is that the bottles are able to hold more molecules of air as the air molecules inside the bottle get smaller, right? So it's able to draw in more air. Now, here's where it gets fun. Step two of this is that we are going to use little moist paper towel squares to cover the opening of the bottles. And we're gonna push them down, seal them with a coin. All right, so like I said, I've got some dimes, I've got some quarters. We're gonna try out both to see what happens. So we're gonna do that right now. All right, so I'm gonna take some paper towels and put them in the sink, get it wet. I'm not gonna show you that part because it's gonna be really hard to do while I'm holding my camera. But I'll be back in a second and I'll show you what I've got. All right, be right back. Okay. So here we've got my bottles completed. You can see that they each have a scrap of moist paper towel on top and it's weighted down with a coin. So 3 of my bottles have dimes and 2 of them have quarters. All right. And I've got like I said, the 2 different size plastic bottles. So the 2 different size plastic bottles, one each has a dime and one each has a quarter, so that I can sort of see the difference of what's going to happen with each of the different size bottles. Okay. And I decided to go with a dime on my glass bottle because I'm not sure if it's going to work in the first place. And so I'm going to make it as easy as possible. So these are going to stay in the freezer for about another half hour. And then we're going to do the next step. So we'll see you then. So we are now going to take our bottles out of the freezer. We're going to do it one by one so that they can stay as cold as possible while they're in there. And we're going to see if we can make these coins pop off of them. So bear with me. First one. Oh no. Oh no. One of my bottles fell over. Ruined. Okay, well, the good news is that I still have 4 bottles left. So good thing I did more than one. All right, so this changes things a bit. We're going to start with the smaller bottles because the one that fell off was the, actually, no, I'm going to start with the one in the back, I think, because that is the bottle that's like the 17-ounce size that has a dime on it. So this was the one with the quarter on it. We don't get to see that anymore, but we still have 4 left to go. So there's still plenty of coin poppage, fingers crossed, to see. All right. On second thought, I'm going to start with what's in the front here. So here we go. So what I'm doing is just warming up the air that's inside this bottle. And it should pop the coin off as the air pressure grows. We'll see. Because again, like we talked about, the air, as it cools, compresses, it gets smaller. And so therefore, when the bottle is open and cooling inside the freezer, it should have been gathering more and more air than it could handle if the air was warm. So now we're warming the air, and it should pop this off because the pressure should grow. It doesn't feel super cold in there, so I'm wondering about that. Interesting. It certainly seems like we've got a decent seal on here. I'm not getting any action with this, so let's try another one. Let me see. It may be that a bottle this size doesn't hold enough air to successfully pop a coin off. That could be our answer right there, right? Like, it could be that it needs a larger bottle to get up enough pressure, right, to hold enough air for the change in pressure to make enough difference to pop the coin off. That could be why this isn't working. And that would tell us something, right? That a bottle this size isn't going to work. So, all right. Let's try the bottle from the back of the freezer. All right, so this one should be good and cold. This is a larger bottle. So another thing I'm wondering, as I'm looking at this, is if the paper towel sealed up the bottle well enough. Because there's like a little wrinkle here. And I'm wondering if what's happening is that air is like escaping out of that. Another thing I could try would be doubling up the paper towel so that it gives a better seal. In doing that, we might run the risk of not being able to move it with the air pressure. I don't know. Lots of reasons why this might not be working, which are all like valid scientific discovery, right? Why didn't your experiment work? There's lots of reasons. All right, this one also doesn't seem to be working. Okay, we have 2 more to try. We'll try this small one. It has a bigger coin, so I expected that it would be more difficult to move the coin. See, it's got a quarter as opposed to a dime. But it might give a better seal, so that's a potential positive. But it doesn't seem to want to do the trick. Yeah, it's not like, I was wondering too if they were like frozen together, and that doesn't seem to be the case. But yeah, this one seems like it's got a decent seal, but it doesn't seem to, I mean, as far as I could tell, right? Oh, yeah, but it doesn't seem to want to do anything. Okay, so that might confirm our theory, right, that these little bottles are just too little to have enough air. So we have one left. It's our glass bottle. This was not recommended by the experiment in the first place, so we'll see what difference that makes, right? Perhaps it'll behave just the same as the plastic ones. Perhaps it'll do better. We'll see. It is very cold, so there's that. Definitely not sure this one got a decent seal. I think what I'm going to do is try this again and see if I can get a better seal, which is like tricky to do when you don't want to take it out of the freezer to like warm it up, but I think it might be really important for this. Because otherwise, when the air warms up, what happens, right? It just like slips out that little crack as opposed to blowing the whole top off, which is what we wanted to see. This bottle is still very cold though, so there's still hope. You can see where my hands have been warming it up. It's defrosted. But yeah, you would think that if it got a good enough seal, you would see, I don't know if you can tell from the video that it's sort of, I forget if it's convex or concave, but it's sort of bowed in, indicating that the weight is still weighting it down and that there's not like air pressure pushing back up on it. And you would expect that if there was a good enough seal that it was going to do anything, you would see that sort of buckling up or bowing up as the air heated up inside the bottle. But like I said, I suspect there was not a good enough seal on this to make that work. So I'll definitely take that into consideration next time and do a better seal. sort of tamp it down all the way around to make sure it's on there real good. I had thought that the coin would just sort of push it down enough to seal it around the edges, but I believe, incorrect on that. See what happens when you assume when you're trying to do experiments. It does not work. Well, this bottle is also getting warm. I don't expect there to be a whole lot more cold air in there that needs to be warmed up. And I wondered too what difference the size of the opening of the bottle would make, but I don't know, without having any of these work the way I expected them to, I don't know that I can test that in any reliable way. Doesn't seem to have made any difference one way or the other. All right, well, I believe that's about as warm as it's going to get for now. All right, well, so far this has not worked. I might give it another try and try tamping it down a bit more. If it's working for you at home, I want to hear about it. I want to hear exactly what you did. And I hope that, you're having fun playing along at home or trying it along with me. And I hope that yours is working more effectively than this. Let me know. See you later. Hey folks, so we are now in my home and I am going to redo the experiment, and the two things that I'm going to try to do better this time are, number one, I'm using a deep freezer, which I am hoping that, even though I've got it open right now, that it will sort of keep the bottles cooler than the upright freezer. And I'm also trying to be more careful to make sure that I am thoroughly sealing the paper towel on top here. So those are the two adjustments that I'm trying to make. I'm also using a thicker paper towel to see if maybe that makes any difference. I have no idea if it will. Let's see. So we're doing, again, like a quarter on each of the bottles, the different sizes, and a dime on each of the different sizes. Again, I'm just trying to make sure that they're as sealed as I can get them. And then a quarter on the glass bottle. All right, we're going to seal that up and let it go for half an hour. We'll see what we get. All right, welcome back to my basement. We are going to try this again. So I've got all my bottles in the freezer right here. I'm going to open it and take them out one by one, and we're going to do the same warming technique that we did yesterday. We're going to see if this works. Here we go. All right, so good news is that they're all sitting upright, so at least there's that, right? All right, so I'm going to start with one. I'm going to start with the big plastic bottle with the dime on it. Let's see what happens. All right, I think this is not going to work, so we'll move on. I'm going to do this a little more quickly today, because if this doesn't work, I have another idea. It's going to be less dramatic, but might actually work. So we'll see. Let's see first if this works, and then if it doesn't, we'll try something different. Because by hook or by crook, we are going to demonstrate what, if any, effect temperature has on air pressure. That's what we're trying to measure here today. We're trying to do it in a fun and dramatic way, but we will measure it one way or the other. Or at least demonstrate it. It's interesting because this certainly seems pretty stuck on there. So like, yeah, this is definitely like sealed on there. But yeah, I'm not getting any traction with this. We'll do all of them, but at this point I am expecting to have to pivot and do something different. I do think that generally speaking, I guess maybe if I'm sort of expecting this to pop off, I shouldn't aim it towards my face. Just in case at this point. It does seem like I got a better seal on these. So that doesn't seem to be the issue. Yeah, it's just not working. 2 more to go. Well, that one just did not. That one was also frozen to the side of the freezer and therefore came off before I could pick it up. So that's that. One misfire, as usual. That's fine. All right. And we have left our glass bottle. Let's see if anything happens here. This bottle is always so much colder. Glass just retains so much more temperature than plastic. Oh, it's making my hands very cold. Very cold. All right, well, most of the bottle feels significantly warmer at this point. So, all right, I'm going to call this and I'm going to pivot. I'll be back in a minute. Okay, so I'm going to do a couple of things at this point. and we'll see what happens. So the first is that I've put one more bottle of this size back in the freezer. I'm gonna try making more of like a plug with the paper towel and the coin than just draping it over. So we'll see if that makes any difference. Make sure we get a good seal. And the other thing that I'm trying is that I'm just putting some plastic wrap over this one. It's just some cling wrap, and I wrapped a rubber band around to make sure it's sealed. So what this is going to show us, one way or the other, it's not going to be like a dramatic pop, but this is filled with room temperature warm air, right? It's got a little bit of give, but it's not like smushed flat or like bulging out. This is going to do something, right? If temperature has any effect on air pressure, this will do something in the freezer. And it will do something else when we get it out and let it warm up, right? So we're going to see, because this is sealed now, no air is coming in or out of this. It's just going to be what happens to the individual air molecules when they're affected by temperature, okay? So let's find out. I'm going to stick this in for another hour or so, and we'll see where we go. All right, here we go. All right, so we're here to do two things now. We're here to put this little damp paper towel wrapped penny on the top of the open bottle in there, and hopefully this will be like a better sort of more plug-like seal. See, that works. And we are also here to see what has happened to our sealed up bottle that had the plastic wrap over the top. What's it going to look like? I don't know. Let's find out. So, first, this is just not. All right, let's see. Maybe that would just plug in there. And then this, look at this. Remember what this looked like before? It was definitely had more give. And I don't know if you can see or hear, but it is literally expanding in my hands. This is cool. So I'm not squeezing it at all. That pop was just literally the air expanding within it. There's like a little divot here where the air has sucked it in. Yeah, did you see that just pop out? So that and this, so this definitely shows us what we were trying to see with the other ones, which tells me that they definitely weren't sealed nearly well enough. But yeah, this definitely, the air pressure has gone way up. So interesting. Yeah, this definitely, I feel like, has shown us what we were trying to see with the other experiment. But yeah, this is like taut and like pushing out. This is now much, it's like closer to where it was before, but even tighter somehow. So the air has definitely expanded in it. It like, was pretty smushed when I first got it out, but now has expanded to be pretty tight. So that is cool. That definitely shows us that the air compressed when it was in the freezer and has definitely expanded in just a couple of minutes since I pulled it out of the freezer and it's warmed up. So this does tell us that air does compress in cold air in cold and expands when it warms up. So if nothing else, this is pretty cool. So I'm going to let that other one sit with the plug in it for another half hour or so, and then we'll test it out and see if we can get a good popping reaction. And if not, at least there was this. Again, let me know how things are going for you at home. I hope they are being more dramatic than my prior attempts, and we'll see what we can get here at the end. All right, see you in a minute. Okay, so this is our last ditch effort to see if we can make a coin pop off of one of these bottles. We're going to give it one more go. And if not, we have at least demonstrated the effect that temperature has on air pressure and on the size of air molecules. So I feel like we've at least won with that. All right, I feel a little encouraged because this bottle seems a little bowed in. So, I'm getting some like bubbling going on here, which tells me that air is probably trying to escape through the paper towel and maybe did. So that's interesting. Um, so that definitely tells me that like air was trying to come out of here because it wasn't like boiling, right? That wouldn't make any sense. But certainly, I think what that means is that somehow our air was able to get out around the coin and like through the paper towel, which means that probably we're not going to get any poppage. But that was still a very dramatic thing to have happened. Um, I don't know if that was a result of me like squeezing the bottle a little bit or gravity or what, but that definitely did just like bloop off of there. Um, at any rate, I feel like, yeah, we have demonstrated that that air does in fact constrict or shrink in cold and expand in heat. Another interesting thing that I want to show you, remember our bottle that we worked with a little bit ago that I just put the plastic wrap on top of. Do you remember how the plastic wrap was kind of like bowed at the top? You probably can't see that, it's too subtle. And the bottle got like really expanded. And I was thinking to myself, why did it seem like there was more air in here than before? And it doesn't seem like that anymore necessarily. This is still pretty taut, but isn't necessarily like bowed out in the same way. But I think, I think that this is probably not like 100% of a seal, right? So I think probably what happened was over the like hour that this was sitting in the freezer, it did seep in a bit of air, right? Not enough to like fill the bottle and keep it, you know, straight, or not compressed. But enough that there was just a little bit more air in here when we took it out. So it actually expanded a little bit more, right, in the first minute or two than it had been when I first put the seal on top of it. And now that has sort of dissipated a bit because again, I think just a tiny, just enough air has leaked out to relieve the pressure. So that really, I think, tells us something about how much of a tight seal you would need to get like a perfect, sort of a perfect reaction. This is more of a real world demonstration, but I hope that you have enjoyed this. It has been a bit of a frustrating time for me, but I have enjoyed figuring out ways to try to work around things and try to demonstrate the properties that we're trying to demonstrate despite some obstacles, um, like you do in science, right? When you're trying to figure something out, try a different way. So we've learned that if almost nothing else, it's not true. We didn't learn nothing, right? But we have also learned that sometimes you just have to try something different and see what it tells you. So this has been STEM Shenanigans. We will be in person at the library in June. So check out our website and the Delco Libraries.libcal website for our calendar and register. And we're going to be doing some fun things in person at Sellers Memorial Library in Upper Darby. And hopefully I'll see you there. All right. Take care, y'all. See you later.